I'm getting ready to do some suspension work on this old Ferrari. And I know what you're saying, Mark, that's a 1980s GTS. That's a flexible flyer. You can't put good suspension in a car like that. They're just way too flexy. It'll never work. So today what we're going to do is we're going to measure what the chassis stiffness actually is, because I don't really think it's that bad, but we'll find out. So that's what we're going to do. And the way that we're going to do it is pretty simple. So I've got the car up on jack stands. The jack stands in back are right on the frame, right about where the axle is. I've got a jack over in the far corner, again, right about where the axle is. On this side, I've got the actual jack and I've got a dial indicator. And that dial indicator is going to tell us how much the car moves. Without the engine in the car, the way it's sitting right now, it's going to be, I don't know, 2,200, 2,300 pounds, maybe about 2/3 of what it should be. And those jack stands are not out at the wheels. They're at the frame, right? I can check it with a tape measure, but just by eye, it's about half. So the wheel will move twice as much as the frame does, but there's not enough weight in the car either, so we're only going to get about 2/3 the real number. So I need to multiply by 1.5 when I'm all done. So multiply by 2, multiply by 1.5, and that'll be the total stiffness in both directions, which is actually double what you would normally measure. You normally measure just in one direction. We're going to measure in two directions, and I'll show you why. With the engine out of the car, the car pivots. Right now, this jack stand is just a little bit loose, not quite touching. So it's touching on this one, it's touching on that one, it's touching on the jack in front. I'm going to jack the jack until this jack stand is firm, and that'll be our 0 point. I'll zero out the dial indicator, and then I'll jack it up until this other jack stand is just barely not touching. And again, that will be exactly double the chassis stiffness. But then we need to multiply by 2, so that'll work out. But then I need to multiply by 1.5. So it'll be basically 2/3 the final number. So let's get going, see how that works. Again, so we'll jack a little bit. There's the needle. I already did it once. I kind of know it should be right about there. Let's go check. And there it is, tight. I just moved that corner 20 thousandths, and that's locked tight. That's locked tight. Okay. And again, as I said, I already did it once, so I know the answer. So right now, there's the dial indicator. There it is. We're going to need to go about 350. There's 1, 2, 3. And I'll just show you I'm not making things up. This jack is still tight. Should be anyway. Sorry for all this camera moving. That guy's still tight. Let's go up another 50 thou. Watch the needle, 50 thou, halfway around. There. That's 350. Let's see. And there it is. So 350 is the number. That's only, again, 350, it's on the frame. That's half because the wheels are wider. So the number would be times 2. But I went 2 directions. I went from full down to full up. So that cuts it in half. So 350. But then that's 2/3 of the real number. The real number is 1/2 inch. There's our answer. The frame twists at 1G, 1/2 inch. Not too bad.